Okay, well, let's get this started. This is Destry Atkinson from Long Building Technologies. Thank you to everyone for joining for the long coffee break. This week we are doing Mars Air Curtains. Pretty interesting product that we've run for a few years now here in Salt Lake City. I've got Chris Burke, sales engineer from Mars, presenting, and I'm just going to let him take it from there. There's a lot of good reasons to use these as things such as temperature, separation, and bugs, etc. But also a lot of energy savings value to this as well. I'm going to let Chris go ahead and Chris Burke's going to take it from here, and we'll let you guys ask questions in the chat, and I will address those at the end. So we appreciate you guys joining. Thank you. Go ahead, Chris.
Thank you, Destry. I appreciate the warm welcome, and thank you everybody for joining me this morning. Good morning, good afternoon, where I am in beautiful Southeast Florida. Today we're going to be talking about Mars Air Curtains. Really, the air curtain technology as a whole, how it's evolved, a lot of the new technologies, changes in baseline energy code, and so forth. So I'm going to walk you through this PowerPoint, the agenda here today, how air curtains work. We'll get everybody on a level playing field as far as the basics, theory, etc., operation, and then we'll get into some of the benefits, and that's the crux of the PowerPoint that I really want to focus on. But why air curtains, and what are they used for, and really where can I have an effective application where there's problems at the end user facility, and we need to solve those with an air curtain. I'll be reinforcing some of the benefits with our CFD simulation and ROI calculator. And again, I mentioned some changes in baseline energy code, where we are, where we're going. And I'll be talking a little bit about our new products, all around clean air series, okay? How air curtains work. For those of you who are not familiar with air curtain technology, it's pretty simple as far as moving parts and components, okay? But what we're doing is we're recirculating inside air. We're always mounted, not always, but 90% of the time mounted on top of the opening, okay? We can mount on the side if there's an obstruction on the top, or if we just really need to control that airflow and make sure there's no slapping of air at the floor, we can side mount that as well. But most of the time we're mounted on top of the opening inside on the conditioned side. So what the air curtain is going to do is it's going to raise up that conditioned air, that inside air. We're going to raise that velocity of that air up through a series of motors, depending on the lengths. We call them motor fan assemblies, okay? Either a cross flow design or a forward curve centrifugal design, okay? So that's the operation. And what we're doing is we're using air as an insulator. Air is a great insulator, right? Great as far as keeping environmental separation, keeping the inside stuff in, I call them like the good stuff in, to improve sanitation, improve safety, lowering heating and cooling costs. The runtime on the main HVAC system is really going to bring a favorable ROI, supporting quality controls, enhancing worker productivity, creating a comfortable work environment, that creature comfort environment that we so yearn for on those hot and humid days and so forth. Also, again, on the outside, main purpose, we're keeping that dust debris out. We're eliminating any fumes or odors from migrating into that space. Flying insects, fly control, we can provide a solution there. Wind gusts, and again, any airborne pathogens or viruses as well. We're keeping that stuff out, protecting the inside of that building, okay? CFD simulation, seeing is believing, correct? We use CFD simulation to see the invisible, okay? For those of you who are not familiar with CFD simulation, it stands for computational fluid dynamics. And it basically looks at, hey, the flow of a fluid. How does that flow of a fluid move into a space when it's affected with various temperatures and speed? It's highly credible. Boeing uses it, GE uses it to simulate the flow of a fluid, Newtonium, non-Newtonium, when it enters a space and it's interacting with different temperatures and different at various speeds. Okay, so this CFD simulation shows temperature distribution after 10 minutes, okay, with those doors open, air curtains off. So let's think of a large manufacturing facility here. Let's think of those loading docks and doors, loading doors and docks open for substantial time loading and unloading that product. We're typically, again, going to provide an effectiveness about 80%. So if you picked up the ASHRAE handbook, you're going to get about an 80% effectiveness with the air curtain running versus the air curtain off. But you can see here, we have 70 degrees inside, okay? We have 20 degrees outside. The building's under a neutral pressure. There's an 8-mile-an-hour wind load against that building 20% of the time, okay? So as you know, there's a lot of boundary conditions on a CFD simulation. It's constantly changing. This is just a snapshot in time. But you can see those loading doors, warm air rises, correct? Cold air sinks. You have a vacuum effect occurring there, and you're pulling in that outside, that cold air, that outside air, that 20-degree air, and that warm air, conditioned air is escaping through the top. Okay, so you can see here on the left, it's a really good image of what's happening inside that building when you're having temperature delta, okay, stack effect at that opening, and then obviously you have a pressure delta. Those are the two ways outside air enters that space. So the larger the temperature delta, the larger the pressure delta, the greater amount of infiltration air across that opening, okay? On the right-hand side, you can see here the vestibule, the main vestibule entrance. Without that air curtain, that unit heater is going to continue to run, try to keep that building temperature, space temperature satisfied, okay? And then obviously on the right-hand side, you can see what that inside temperature looks like when that air curtain is running, providing that environmental separation, okay? So from here, we can say, hey, all right, doors close without an air curtain, and we have to get that space back to room temperature. That heating and cooling system has to run, okay? So without an air curtain, we have a greater loss, as you could just see on the previous slide, versus with that air curtain, okay? So that runtime is reduced on the main HVAC system. So here is an ROI calculator. It's located at marsair.com on the center page in the top left. I'd highly encourage you to play around with this. All the conditions are there for you. We use NOAA weather bin data. We use local utility costs. But this is an ROI. I ran this for Chicago, Illinois. Sorry, I thought the Denver one was loaded here because I did a Denver lunch and learn last climb. But anyways, you can see the temperatures here. You have your door height and width. You have your business time, operation time. How long are those doors open? How many days a week? Summer season weeks, and then obviously my winter season weeks. My cost to run. Okay, I'm sorry, cost of heating, and then my cost of electricity here. And then I obviously have my temperature for those 26 weeks during the winter months, and then my 26 weeks during the summer months. I have my wind speed. I can change that. It's a 10 mile an hour, 20% of the time using NOAA weatherman data. And then I have all the costs obviously here located, cost to purchase the air curtain. So we're taking all those costs in, and then obviously the installation cost. But you can see here, we're looking at an ROI of about 2 years. Okay. And that's a 12 by 12 opening. Temperature is obviously, as we just mentioned here, and so forth. So you can load all this in for your local conditions, your applications, and get an ROI. When that door is open more than, I'd say, 2 hours a day, and our delta T is greater than 35 degrees, you're going to have an ROI probably around 2.5 years. It's pretty consistent when I ran all the ROIs over the years of doing this and seeing where that ROI lays in. So another benefit. So we talked first about the first benefit of an air curtain, energy savings. And that's really where the focus of this meeting is pinpointed on. Typically, air curtains have been used as looked at just purely as sanitation. We want to keep those flying insects out, but we're really evolving, and our message is all around energy savings, which gets us to this slide. A major win for us, our industry as a whole, air curtain industry as a whole, is we are replacing costly vestibules. So now air curtains are approved as an alternative to vestibules. Climate zones 3 to 8. Space, single dwelling space greater than 3,000 square feet. Main entry, there's some exceptions there that obviously go into the exception, and I can email that off to you guys. But we've been now accepted as an alternative in IGCC, IECC, and ASHRAE 90.1. Okay, we spent probably $500,000 lobbying these governing bodies and said, hey, here's our quantitative data. Here's our proof on how we're more effective than a vestibule in preventing infiltration. And we were able to illustrate that vestibules are good. Yes, we're not necessarily saying do away with them completely, but if there's space constraints and there's construction costs that we need to really hone in on, air curtains are a great alternative to that. We were able to show that you're still having a lot of infiltration with vestibules when both doors are open. Standard 7-foot wide vestibule, you take one step in, high traffic, you got both those doors in, creating obviously an infiltration from a wind tunnel effect. So air curtains are and have been approved as an alternative to vestibules. Clean Air Series. Unfortunately, now with the pandemic and conditions the way they are, sanitation has become critical. And we said, hey, we need to react to the building conditions needs and end users needs as well. So we said, hey, what can we do? We said, let's provide a product with a UV light. It's a dual purpose bulb. It's a UVC, UVV. So we're eradicating any airborne pathogens, et cetera. We're also neutralizing odor. That's mounted, there's a ballast that spans the entire width of that air curtain. It's mounted right in front of the intake here, as you can see. So when that air is drawn in here, okay, it's going to pass over that light, and it's going to have a high intensity log here, and it's going to be able to neutralize any of those odors, and also, again, eradicate any airborne pathogens, et cetera. We also have a HEPA filter as well. So any airborne particles down to 0.03 microns, we are able to catch. We can use both of these in conjunction with each other as well. And then we have our triple threat product here, which is called our air wash system, which incorporates all three technologies. So we have the UVC, we have the HEPA, and then we have the bipolar ionization system as well, okay? So they're mounted on each side of the opening, all right? All three of those technologies are on each side, and we're blowing that air across. So a lot of meat processing facilities, a lot of food distribution, a lot of clean room applications, ER applications, those are really where we've been getting a lot of positive feedback with these three technologies incorporated into the air curtain itself, okay? Think of that as a human shower. And this is just how we really stack up versus our competition on this product. We have technology that no other air curtain manufacturer has built into their product. They either may do just a HEPA filter or a UVC light. We're incorporating obviously all three of those in there as well. So I listed here some of the pros and cons to our UVC product versus in our triple threat air wash system product versus the competition. Simple Link, revolutionary control system that we've developed that makes that air curtain a lot more intuitive, okay? Typically air curtains on or off. If you have to vary that speed, it's done by either a PSC motor, a 3-speed motor, or a variable speed switch, but it's a manual operation. This Simple Link controller, it's a digital controller, okay? It's smart. It's all smartphone activated. There's a router inside that air curtain with a QR code. You just scan that QR code, and everything is downloaded. All the programs are downloaded. But it's going to make that air curtain intuitive, meaning it's going to ramp up that airspeed and down, ramp up that airspeed up and down, depending on what's needed, depending on that temperature delta, depending on that pressure delta that I talked about earlier. Okay. There's also preset modes in there. For an example, one of our modes, when you first set that up, is going to look at, hey, door operation. Do I have to, run a time delay at certain times? What's that door traffic pattern doing from 7:30 to 8:30 whenever everyone's entered the building, and it'll adjust the motorcycle accordingly. So very, very intuitive, range up to 40 feet, even with an obstruction. It's easy to connect. Wi-Fi is not required. Again, there's a router built into there, and this is our Simple Link 2 that is fairly new, revolutionary technology in the air curtain world. And that is available. And that's all I got. Destry, is anything else that you'd like to hit on?
No, that's great. That's one of the things you pointed out there is getting rid of the vestibules and having the air door there. That's pretty awesome technology. I had an owner a couple of years back that just tore the vestibules off because they were ugly, and then they had a problem. And then I was able to help with the solution with the air doors rather than adding back on the unsightly vestibules. And anyway, we sure appreciate you doing that today. If anyone's got any questions, we'll hang out for a second here and let you type it in the chat. Otherwise, Chris, thank you for doing that. And anyone on the call that has a request for Mars Air doors, please reach out to your long salesman and have them help you out. Thanks for joining.